So very nice to meet you. My name is Alex. I'm very happy to be here. I will be talking about reliability of cloud scale hardware through performance and health monitoring using on-chip telemetry. Prodantex is actually leading a new category. We've been founded in 2017, and we are serving customers around multiple segments as automotive, data centers, communications, and we are basically silicon proven at 28, 16, 7 nanometer, and 5 nanometer. And the challenge that we are solving is that today there is a big gap in between the demand to be available 24/7 without failures by the leaders in the industry. However, to accommodate that, the chip manufacturers are basically using advanced processes, super complex architectures, a lot of trade-offs between reliability and performance, and that overall leads to escape in defects and eventually to failures in the data center without a clear monitoring solution. And that's the challenge we are trying to solve. The way we are solving this challenge is by creating a visibility at every stage of the life cycle of the chip, from chip design to chip production, system production, and in field. Basically, we are creating a baseline in the data, in the language that all these stakeholders are speaking, by generating data from the chip that will be used across all these test stages. So the solution that we are using basically is a multi-pillar solution. The first layer of the solution is deep data generation using Universal Chip Telemetry, and we are doing that by integrating agents into the IC. These agents are monitoring critical parameters in many locations of the chip. After the data is being extracted from the chip, we are using different kind of analytics techniques and machine learning techniques to analyze the data and in the cloud or by different kind of edge applications that enables the users to get an insights and to take decision as the chip is running either in production or in field. So what kind of agents are available? We are segmenting them into a couple of categories. The first category is the classification and profiling agents. These are the agents that encapsulate the process variation and capture the signature of the process. And as you might know, the process will eventually affect the performance of the chip. It's a very important parameter to track. The second layer here, the second category, is performance and degradation monitoring. So we want to know if the chip is healthy. And the way that we are doing that is by monitoring millions of logic paths inside the chip by the margin agents, which are basically measuring the remaining margin relative to the clock operating cycle. The next category is interconnect and performance monitoring. And this layer of agents monitor the connectivity and the health between basically two components, two chips in the package. It can be ASIC or HBM or two chiplets, as was discussed in some previous section here. And the last category is operational monitoring. And these are basically the agents that are monitoring aspects like voltage fluctuations, cycle-to-cycle jitter, workload, temperature, etc. So in that way, we create this complete package of monitoring. A few key points that the agents are collecting parametric data. They are high coverage inside the chip, and they are resulting in a minimal penalty to area or to power. And of course, they can operate in mission mode and not require some test mode. So when we are looking basically on the results of the agents, which are transferred to the analytics platform and available for the user, we can see a couple of layers of analytics and different values. So for chip production, for example, we can achieve, or our customers can achieve, faster ramp up with higher confidence by our technology, improve DPPM reduction, and shift left decision, basically moving some of the insights and visibility from the in-field and closer to the manufacturing in wafer sort or final test. In system production, we now are moving into a situation that the agents already measured at some point and now operating in the system. So we can compare across multiple stages and find some discrepancies and issues. Also in system, we can perform power optimizations and system application optimizations because the agents are located in multiple locations. Eventually, the last stage is in field, and while the chip is operating in the field, we can monitor different aspects like degradation and alert on failures before they are happening by predictive maintenance or some continuous monitoring of health parameters of the chip. And in that way, basically to improve the reaction to failures in the field. So few examples to the type of analytics that we are doing across multiple stages. So the first one is outlier detection. So you can see here on the left side, in the left plot, basically this is a traditional way to perform outlier detection, in which you plot a distribution of some parameter, and if the data is outside of the limits or it's different than the other, so you screen that. But this is not enough, and sometimes there is shift within the population that are not detected. That's where our technology comes into place, and by the measurement from the agents, we can create a model and predict what is the expected result, for example, of IDDQ, of a leakage current, and compare it to the actual parameter. In that way, we can detect much better the different outliers and expose them versus the population, because we know what to expect and we have a new baseline for every chip, basically. The second example here is from a system that is operating, and what you can see here is a multi-angle view of all the agents that are measuring the performance of the system over time. You can see here in the different plots aspects like the margin of the system over time. You can see here aspects like workload, voltage fluctuation, and clock integrity. Everything is basically having the same x-axis here, and the results can be overlaid one on top of the other to exactly understand what is the situation with the system and whether the system is underperforming or if there is some issues that we can detect. The last example here is basically a health monitoring with alerts of faults before failure of a chip that is operating in the field, in the data center. We can see here some example of a logic pad that is degrading over time out of the million logic pads that we are monitoring. And using the agents, we are able to detect this degradation, predict when it is happening, and basically recommend to take an action. In this case, you can see a software update that was taking place, and the workload of the system reduced, and the system can continue to operate in the field without the failure occurring. So thank you very much. If you have any questions, please feel free.
So please ask your questions. We have time for 1 or 2 questions.
When do you have to be integrated to be able to provide these analytics solutions? You allowed to do it post? Are you able to do it post tape out, or do you have to be integrated?
No. So the agents are circuits that needs to be integrated during the design phase as part of the chip design. So it should be pre-tape out.
Okay. And what's your consumption kind of to be factored in so people can understand that?
So maybe another comment is that, as part of the integration is automated. So we are providing a tool to integrate the agents in a simple manner.
Okay. I assume you're leaking power, right?
Yes, and in terms of the KPIs that we are looking at, so in terms of area, we're not adding more area to the chip. In terms of power consumption, so it's divided between leakage and dynamic power, and we're talking about a fraction of a % of adding these agents because they are designed to be efficient power-wise. They are mostly digital circuits.
Thank you.
Thank you so much, Alex.
Thank you.